beta tubulin, alpha tubulin, and protofilament, and plus and minus n. 13 protofilament makes microtubules, and it's a cylindrical structure. So now actin subunit. Actin subunit is a single globular polypeptide chain. Single globular polypeptide chain. 375 amino acid and 43 kilodalton. Size 43 kilodalton. It has a monomer rather than dimer. It is a monomer. We know about the previous microtubules, which is a dimer, but it is the monomer. Like tubulin, here, tubulin, each actin subunit has a binding site for nucleotide, but for actin, the nucleotide is ATP and rather than GTP. For actin, the nucleotide is ATP rather than GTP, and also tubulin and actin binding site for nucleotide. But for actin, the nucleotide is ATP. Actin filament considered consists of two parallel protofilaments, where the microtubules consist of 13 protofilaments, and here actin filament considered to be consist of two parallel protofilaments that exist twist around each other in right-handed helix. Actin filaments are relatively flexible compared with hollow cylindrical microtubules. Microtubules is hollow cylindrical structured, but actin filament rarely flexible because there are two parallel protofilaments that exist and twist around each other in a right-handed helix. Here, the meaning of term nucleation, critical concentration, the course of polymerization, plus and minus ends, nucleotide hydrolysis, ATP caps, GTP caps, trade milling, and dynamic instability. Nucleation, critical concentration, the course of polymerization, placent and minuscent, nucleotide hydrolysis, ATP caps and GTP caps, trade milling, dynamic instability. Trade milling is the process. Trade milling is the process where subunit is continuously adding and other side subunit is removing. Here the picture soluble subunit in the T form. Polymer are mixture of T form like ATP form, and D form like ADP form. Here, polymerization followed by nucleoside hydrolysis, 3 subunit nucleation, then polymerization added. Here, placent is at first, hydrolysis lags behind, minuscent is addition slow. In the placent, the addition of subunit is fast, and in the minuscent, the addition of subunit is slow. Hydrolysis process. Here the graph grow, shrink, deform, deform, and there are the difference between the deform and deform addition or removing, and the borderline is trade milling. During trade milling, subunits are recruited. During trade milling, subunits are recruited at the placent. Recruited at the placent of the polymer in the deform and shed from recruited like addition and shed from like removing the minuscent in the deform. The first thing we should know that subunits are recruited at the placent and it is the it is from in the deform and shed from the minuscent in the form of deform. ATP and GTP hydrolysis. Two kind of hydrolysis, ATP and GTP hydrolysis, that occur long way give rise to the difference that occur. ATP and GTP hydrolysis occur the difference in the free energy of association and dissociation reaction at the plus end and minus end of the actin filament or microtubules. Both are same. Actin filament and microfilaments has the same thing of addition and association or dissociation reaction, and this reaction is occur by ATP and GTP hydrolysis, and and the dissociation and association is mainly in the free energy reaction, where at the plus and minus end. At a particular and makes treadmilling possible. When treadmilling possible, ATP and GTP hydrolysis occur in the free energy association and dissociation plus and the minus end of actin and microtubules. At a particular intermediate subunit concentration, the filament growth at the plus end exactly balanced by the filament shrinkage at the minus end. At a particular time, the intermediate subunit concentrate is need to balanced. So the balanced concentration is make by made by the filament growth and other side filament shrinkage. Filament growth at the plus end and filament shrinkage at the minus end. Now filament cycle rapidly between free and filamentous state. The filaments are rapidly rapidly find free and filamentous state. Some subunit in the form of filamentous state and subunit are free from. While the length of the filament, the when the continuous processes of addition and dissociation and the total length of filament remain unchanged, while at this time the total length of filament is unchanged. This unchanged filament length is occur when the steady state treadmilling is occur. Steady state treadmilling require the steady state treadmilling is a term when they require constant consumption of energy in the form of nucleoside triphosphate hydrolysis. Required constant consumption of energy in the form of nucleoside triphosphate hydrolysis. Suppose the concentration of free subunits, the concentration of free subunit is intermediate between Cc critical concentration for a differm end and Cc concentration for a differm end. The same range of concentration where treadmilling is observed. The same range of concentration where treadmilling occur. When the differm and differm in intermediate and the concentration of free subunit. Here some T subunit is free, T from in the subunit is free, and the T from the subunit is free subunit, and their concentration should be in the same range of concentration where trade milling occur. Now, at the end that happen, in the T from will grow, whereas and any end happen, the T from will shrink. On a single filament, the end might grow certain length of the diaphragm but suddenly change in the diaphragm. Some subunit grow in the diaphragm and length of time in the diaphragm. Then other side diaphragm is changed to the into the diaphragm. Diaphragm change in the diaphragm, and diaphragm began to shrink rapidly. Even while the free sabin concentration is held constant. At the at the at the latter time, it might then regain in the diaphragm begin to grow, and rapid interconversion between a growing and shrinking state. A uniform Sabini concentration is called dynamic instability. The change is rapidly shrinkage. It's called catastrophe, while the change growth is risky. In the dynamic instability is thought to predominate in microtubules, and trade milling is predominant is actin filaments.